Hey, welcome you all. We have Anku Rani as our speaker for today's session. Just a few words about Anku. Uh, she is a doctoral researcher at MIT, working on human-centered multimodal AI, and she previously conducted research at Adobe Research on multimodality, and she also um, worked in University of South Carolina, and her research focused on fact verification. She has published in leading conferences like ACL, EMNLP, AAAI, and so on. And so we welcome you today to give a wonderful session. So she's going to be a much more exciting session. Over to you, Anku.
Thank you so much. Excited to be back, and thanks for the introduction, Venkatesh. I'm a PhD student at MIT working on projects related to multimodality and HCI. I use generative AI to build systems that provoke, inspires, and helps us express ourselves. I also visited AIISC back in 2023 and absolutely thrilled to be back. So to get the ball roll, like before we get started with the talk, if anyone has any introductory questions, I'm happy to take them, or we can get started. All right. Think we should get started. So, my work is right now focusing on misinformation and how human and computer interact with each other. So, this is the work that I'm going to present is currently under review at CAI, and the way this talk will proceed is I'll take breaks after a couple of slides and you can ask me questions then. Till then, I'll ask you to note down your questions and okay, so let's get started. So, the work that I'm going to talk about now is dialogues with AI reduce beliefs and misinformation but build no lasting discernment skills. A lot of you might have come across this image on the screen on your screen, which is of an AI generated report of the Pentagon that spreaded rapidly on social media. It garnered thousands of shares before it was being debunked. And this picture actually led to stock market fluctuations as well. So, coming across news like this, and a lot of times when we go on our own social media platforms, Twitter, LinkedIn, it's full of either images or facts that are not true. So, with that motivation in mind, we conducted a study to see whether we can teach humans to distinguish between what's real or what's fake. All right. So AI assistants such as ChatGPT, Claude, Grok are increasingly used to evaluate the credibility of online information, from judging the authenticity of news headline and viral images to answering whether medical claims or political rumors are true. Some of the works are on the slide that I have cited, and you can probably take a picture if you would like to learn more about it. So while recent research in machine learning space has focused on building a lot of systems for fact verification, uh, people have also been running studies to see what can reduce beliefs of human and false claim. So, the conversations with AI to teach humans to detect misinformation or merely shift their belief about misinformation. So, what the conversation with AI does, whether it kind of makes you believe in misinformation, correct your belief, or it is just creating a dependency paradox, which means we are not sure if we are learning or not, or we are just becoming more reliant on the AI. So, some of the methods, some of the research gap that came up from the recent work in these directions are listed on the screen. While both human and machine based fact checking systems have been used to annotate, um, have been used to annotate and remove false information from online spheres, they struggle with the speed at which misinformation is produced or spread, or they just fail to be accurate. Additionally, machine learning based detection algorithms are computationally very expensive. So we struggle to keep up. I mean, they struggle to keep up with the speed at which misinformation are generated and at the pace with which we could, mark them and tell that, okay, this is a fake information. So humans are also poor at detecting AI generated content due to its increasing sophistication of generative models and a lack of knowledge about their outputs. Adding to this challenge, research also shows that when false information is explicitly corrected with humans or machine based corrections, people retain their initial beliefs, and that is called a continual influence effect. And the paper is cited over here to understand more about it. Okay. So, to understand whether conversations with AI can help us learn how do we distinguish between AI generated content versus real content, we designed a system for it that I'll talk about in my later slides. We also conducted a month-long longitudinal study wherein we recruited a lot of people who interacted with the system to then study whether our system was effective enough or not. We found out from the study about a dependency paradox that I'll talk in detail about. And, and then we ran a bunch of conversation analysis from those chats between human and AI that was generated through the system. So the question we are asking is, do dialogues with AI chatbots actually build lasting misinformation detection skills, or do they create dependency that undermines humans' independent judgment? I'll take a quick break, a quick stop. If anyone has any burning questions, thoughts, I would be happy to chat, and then we'll move to the next slide. Okay. Okay, I think is there any question or we can move ahead?
We can go ahead.
All right. So talking about data source that was used to run this study, there's this work called Mirage News that contains news headline pair, and we randomly selected 55 news articles from Mirage News. It consists of 12,500 high quality image caption pairs, both real news items and AI generated pairs using state-of-the-art generators. So the paper worked on creating those data set, and we used it from their work, along with the ground truth labels, that is whether it's real or fake. So the figure that you see on the screen represents some of the examples from the data set. These news items that we selected were passed through the system we designed and then was prompted to guide users towards the correct answer. And the items of this data set is quite diverse. It includes topics from elections, protests, court proceedings, health matters, disasters, and so on. So let's talk about the system design. So in order to design the system, we created a web-based AI chatbot to investigate whether dialogues with AI can help humans learn to distinguish between real and fake content over the course of month-long study. The system presents participants with real and AI-generated news headline image pairs and then engages them in conversation design to guide them towards accurate authenticity assessment, which means that the system is actually guiding you towards the ground truth, which is whether it's actually real or fake. So to evaluate the effects of an AI chatbot on misinformation discernment, our system implementation closely followed an approach on generating persuasive dialogues, which what that means is we combine LLMs with web search And we prompted the LLM to generate persuasive conversation guiding the users towards the right answer. So the three components of the system were first is your React-based user interface. The second is using GPT-4o for dialogue generation that receives message from user and then does a Google search and then fetches the Google search result to generate the response. And then in the backend, it's actually using Google Search API that returns the relevant evidence. And then we had a system that logged AI response, participant data, metadata, and so on that we later used for analysis. Yeah. If anyone has any question, I'm happy to take them now for on the system design.
We can move on. I think
Okay, there's a question on the chat which says, will the slides be made available? In the last slide, I have a QR code that you can scan for the entire paper. So I think you will have all the information through the paper. Okay. Now let's talk about let's talk about the prompting strategy. In order to build the system, we
Anku,
tested.
there's
Okay.
a question.
Maybe you want to come before. Just here. There is no.
Okay, talk.
Yeah, so my question is basically you use a custom search engine uh, powered by Google's API, right, to basically get relevant information from the web related to the user's query. But is there any way you verify those queries that are returned by Google if it is actually relevant? Because that is actually. So, is there any metric to also measure the reliability of the source that is returned?
Yes. So we did conduct a evaluation based on the generated output, and then there's some evaluation that I'll show you in the next slide, which will talk about the numbers, how accurate is the system we have designed, right? So it's not 100% accurate. So what we did was I'll talk about it in my later slides if you could hold on to that question.
Thank you.
Yeah, thanks for asking. Okay, so let's talk about the prompting strategies. We worked on a bunch of prompting strategies wherein we call them as news forensic expert, persuasion, and combining both news forensic expert and persuasion. What I mean by news forensic expert is, as you can read in the prompt, I want you to work as a news forensic expert for news headline and images. Check if the image has artifact attribute, for example, asymmetric eye iris, irregular glasses, shadows, weird hands, unnatural edges, and inconsistent lighting in the background or strange background, and so on. What the persuasion prompt does is it is asking the system to effectively persuade users to stop believing in the false headline plus image pair. And then you will be having a conversation with a person. And then I'll talk about what exactly is the input in later slide, which is we are also taking a belief level from user and they mark it whether it's real, 0% real, 100%, whatever is their belief. And then based on that, through persuasive prompting strategy, we generate dialogue to push users towards the right judgment. So when we were testing all this prompt, what worked best for us is combining the news forensic expert, that is AI generated image detection and persuasive dialogue generation, which is the last prompt, which is combining news forensic expert plus persuasion. So now talking about system evaluation and I'll try answering the question that I was asked just couple of minutes back. So to evaluate the system, what we did was we tested the system with bunch of conditions. The first condition was Google search is happening on the headline and image is being passed through GPT-4o. The second condition was Google search is happening on headline, but the image is not getting passed to GPT-4o. It's just Google search on headline that is just getting the evidence out. And what we found was you can look at the numbers. It's pretty low for example, 78% overall accuracy. What rejection rate means is a lot of times when you give GPTs or AI assistant questions related to politicians, for example, if you give it an image of Trump and ask certain question, it might just reject, it might just say that, oh, I cannot answer this because guardrails have been built for that. So for that, we measure rejection rate and we want to make sure the rejection rate is low in order for the system to work well. So condition 2 is Google search on headline, no image on GPT-4o. Condition 3 is no Google search plus image on GPT-4o. And condition 4 is no Google search, just headline on GPT-4o. So what worked best in all these cases are the third prompt, which is news forensic expert plus persuasion, which I explained in my previous slide. And then Google search goes on headline and image goes on GPT-4o. So that led to 100% accuracy, rejection rate 0%, accuracy 100%. Now, when I'm saying 100% accuracy, I'm not claiming that the system is 100% accurate. It means that certain sample of images that we tested on, it led to 100% accuracy. Now, what we did was we used around probably 10 images for this, and then we moved on to the 55 randomly selected images that we took to run the entire study. And what we found was the system misclassified 6 items, which we removed from the data set. So the final data set was just 49 items, and the accuracy would be around 86%. So throughout, and then there's a study design that I'll talk about how those 49 items that was actually correct from the system was then distributed across the month-long study. All right. Okay. So let's talk about the study design. To conduct a longitudinal study, it's a lot of work that we do to recruit people, to make sure that they are there throughout all the study phases, and then we reach at certain results that, yeah. So we conducted a longitudinal study to understand how AI assistance affects people's ability to detect misinformation over time. The study ran for 4 weeks with 3 testing sessions at week 0, week 2, and week 4. Each session had 3 phases, which means that people are doing, if you look at this image, you see a before AI phase, which means that participants have yet not interacted with the AI system and they are simply rating whether they feel this X, let's say an image is there and a caption is there, and they are rating whether it's real or fake, and then they are also giving a confidence rating on that. So that's before AI. You see, the next is with AI. With AI means that people are interacting with our chatbot, they are rating the item, and then they are interacting with the persuasive dialogues for around 9 rounds of conversation for us to make sure that participants are getting exposed to it for some time. And after that, it repeats for 4 news items. The study ran for around 1 hour for all these sessions. And in the after AI phase, they rate again news items that they haven't seen before for us to measure whether people are actually able to learn or not. And then there are attention checks in between to make sure people are actually paying attention and working towards and interacting with the chatbot as expected. Yeah, if any questions on study design. All right. So moving to the next slide, I'll talk about how we recruited participant and experimental protocol. So we recruited participant through this online platform called Prolific. We recruited 105 participants. 76% of them were from US and 24% of them were from UK. Of the initial 105 participants, 28 of them dropped while they were completing all 3 sessions. And in the final analysis, we excluded these participants. Along with that, we also excluded participants who fail attention check. So in HCI study, attention check is quite important in case people are not paying attention, just doing the work to get paid. So we removed them from the study. So this resulted in a final sample of around 67 participants who completed the entire month-long study. The final sample had a mean age of from 20 to 63 years old, 53% male, 47% around female. And yeah, the study was also approved, IRB approval was there by MIT's COVIS, and the compensation that participants receive in such work was $8 for all sessions. And if somebody completes all 3 sessions, they get an additional $3. So that's about the study compensation. Now let's talk about the interaction flow. So if you look at this image, it is somebody over here in some violent clash. I would like to see a raise of hand for people who feel this is a real image. Nobody feels this is a real image. That's what I can see from my screen. Okay. Can I have a raise of hands from people who feel this is a fake image? Okay. Okay, I do see some hands. Well, so I think you guys can actually identify this as a fake image. So how the interaction worked was we asked participants, what do they think if this news is real or fake? And if somebody says real, they also give it a confidence rating, let's say 70%. And then they interact with the chatbot system that we built. They go through 9 rounds of conversation, and then they mark the same news article again so that we could measure whether the initial belief changed. And what we see was over here, if you see the first image, one of the participants said real 70%, and when they completed the interaction, they changed their belief from real to fake, and it was 100% after that. So these are some of the interaction flow. What we observed was while people interacted with some of the news, there was belief change from fake to real. There was, so the first thing the AI asks is, do you think the news is real or fake? Please provide a confidence rating from 0 to 100, which is fake 60 if a human says. And then the AI responds, I understand your skepticism. Let's explore this together. And then they say that, oh, this is reported by New York Times, this and that. And then if you look at the last dialogue, the AI asks the user again, what do they think if it's a real or fake news article? So then they say that it's real 100. So there was belief change when participants interacted with that particular item before and after AI. So it means that humans do believe on what AI says. There were cases where we also observed the confidence increased post interaction, which means that if you are unsure, if, for example, this is an example wherein a participant says, oh, this is real 50, and then their confidence increased from real 50 to real 100. All right. So let's talk about the learning effects of current AI system and how did we run analysis on everything that I spoke about. So our dependent variable was item level accuracy, which is if you say real versus fake, if you are correct, you get 1, and if it's incorrect, it's 0. So analysis were restricted to people who completed all 3 phases, as I mentioned, and it was for people who completed all 3 phases and did not fail one attention check, more than one attention check. So items were flagged as seen before was also excluded from the analysis. For example, if you have already seen that news before, it doesn't make sense for people to kind of have conversation with the AI because of pre-beliefs and so on. So that was excluded from the conversation, from the analysis. So our main tests focus on 2 planned within week contrasts, which is with AI interaction and before, and then after AI interaction and before. So to see whether people are learning or it is just creating dependency on AI system. Overall, what we found was with AI system, there was significant increase in discernment accuracy over the month-long period, which was 21% average. And without AI support, the accuracy decreased. So humans lost their independent discernment skills by 15% at week 4 when we asked them to discern unseen news items without any AI assistance. So to talk more about the result, persuasive AI substantially improved accuracy when assisting the user, and our results participants showed large short-term gains when interacting with persuasive AI. Across all these weeks, accuracy on assisted items were marked high, as you can see from the graph with AI support. It's high. So it was an approximate of 21% average. Week 0 was 22, week 2 was 15, and week 4 was 26. And these week by week effects were robust, and they assisted, we observed a gain across all these weeks. The pattern suggests that AI chatbot consistently corrected misperceptions during conversation, and that the strength of this persuasion effect have grown over time. So if you look at this graph on AI support, you could see an increase in the graph. Now, what happened after AI support? When there was no AI, when there was new news items, people were interacting with the AI system, they were changing their belief, but were they actually learning? So the answer we found out was they were not learning. In fact, their independent skills, in fact, decreased with time, as you can see in the after AI support unassisted graph on the right side. Yeah. So let's move to the next slide. Now, we did some conversation analysis as well because participants interacted with the system. There was 9 rounds of conversation, so it generated around 7,000 conversation between human and AI. And we have some interesting findings from those conversations as well. To understand which conversational strategies shaped fake news detection, we applied LLM as judge to classify each of the human AI dialogue into 21 classifier categories that you can see on the screen. So what this classifiers does is it captures specific conversational moves, for example, whether it's asking for image forensics or probing deeper, which is asking questions, or prompting for confidence calibration. For example, image forensics occur when AI asks about visual artifacts or manipulation in an image, while confidence calibration refers to prompting the user to rate and reflect on how they are in their certain judgment. By coding these conversations between human and AI, we were able to correlate strategy with accuracy on fake news item, both under assisted and unassisted conversation. Now we ran LLM as judge on the conversations generated, and what we tried finding was what are the strategies that correlate with learning versus what are the ones that do not correlate with learning. So if you look at this graph, asking about their confidence, playing devil's advocate, or comparing with known facts led to lesser correlation, which means that if an AI is just comparing with known facts, probably humans are not learning because of that. Then what actually made humans learn? It was asking guided question, probing deeper over generated responses, and so on. Are there any questions till now?
I have one. Are you
Sure.
concerned, like your study seems to show that humans, when attached to AI, degrade over time in our ability to think. Are you concerned at all about like a state actor involved in an election process? You know, could it influence humans using a different LLM? Let's say Iran has their own LLM and they provide this information to certain websites using the same technology that you're using. So, like, instead of a positive influence, a direct
Your
negative.
I'm sorry, your voice is breaking. If you could come closer to the system and ask, it would be helpful. Thank you so much.
Well, it seems you're developing a technology to help humanity, but certainly there's a reverse of this, and that
Sure.
is
Yes.
using it as an active war or military technology. So, especially in Ukraine right now, that's happening a lot. So I wanted to
Yes.
get your ideas on that and whether MIT is being asked to work on things like that as well.
That's an interesting question. Thank you for asking that. There are a lot of work that has spoken about, AI is creating over-reliance or dependency. I mean, human is becoming very over-reliant on AI. A lot of us, when we work on something, we are often having a conversation with AI on the back end and so on. So yes, when we started the research, the goal was actually to build a system that helps human, but we had a counterintuitive finding during our study. So it was not, the hypothesis failed, and we found out that humans are becoming worse at discerning misinformation. Yeah. So I don't know if that answers your questions. We can have a follow-up round as well.
In part, yes.
Okay. All right. If you want to ask more, I'm happy to chat. Or yeah. Okay, moving on to the next thing that I want to talk about, which was understanding human AI behavior through this conversation. So we ran a we employed a keyword matching extraction method, which is commonly used in computational linguistics, wherein certain keywords from conversations are extracted. So to do this in our work, we automated the keyword extraction process by providing an LLM with conversation transcripts and prompting it to generate comprehensive keyword list for three behavioral pattern, which is agreement behavior, whether it's human that agrees more with AI versus AI that agrees more with human, independent thinking, whether it's who is thinking independently more? Is it human or the AI? Some probing behavior, which is when human and AI are having conversation, are humans asking questions or is it AI asking questions to human? So just a quick view of the kind of keywords that that the LLM gave us an output for. Human AI agreeing, there's direct agreement, which means humans would say to AI, "Oh, you are right." There's keyword list for AI, that was formal validation, where an AI said, "Oh, you are absolutely right. You are correct. That's correct. You make a valid point, this and that." So through all those transcript, we generated these keywords and measured human AI agreement behavior that I'll talk about. The second is human AI independent thinking, like who is thinking more independently. To measure that, the keywords were I think, I believe, I feel, which is what humans are saying. Whereas in case of AI, it was it seems, it appears, this suggests, and so on. Now, talking about human AI probing, whether it's human that's asking more questions or AI asking us more questions. So to measure that, we had keywords like why, how, what, and so on. In case of AI, it was Socratic questioning. What do you think? How do you feel? AI asks us such questions when we are having those conversations. So now let's talk about the results that we saw. This is interesting. So what we observed is the longitudinal analysis of conversation reveals shifts in conversational dynamics across the month-long period. Human agreement with AI increased from 23% to 28.5% in week 4. Not a lot of increase, but some increase. While AI agreement with humans remained relatively stable and low. If you look at the graph, it's 4.2% and 6.4%. So 4 to 6% is what AI is agreeing with human. Independent thinking abilities. Conversely, humans' independent thinking capabilities remained constantly low across all weeks, which was 7%. So we do need to work towards thinking independently and, uh, probably cautiously making sure we are not becoming over reliant on AI, while AI independent thinking seems to be around 20%. Yeah, and it kind of says that AI maintained analytical autonomy while humans' independent thinking ability did not vary much. And when we talk about the probing behavior, AI is probing humans more compared to humans actually being curious and asking more questions, is what we observed. So together, this suggests kind of a potential over-reliance on AI guidance at the expense of fake news discernment skills for misinformation detection. And in HCI study, we also run thematic analysis. What thematic analysis means is we use conversation transcript and we try finding overlapping themes among participants. That is, how is participant A behaving with respect to participants B, and we try clustering them together if their behavior was similar. To measure, to conduct the thematic analysis, we asked participants 2 questions across all these weeks, which was AI effectiveness. The question was participants responded to, do you feel that the AI taught you how to identify true and false information and images? And the second question was about the thinking process. Participants responded to, please describe your thinking process when reacting to AI dialogue and be as detailed as possible. So we'll talk about some of the responses and clusters we observed in this study. The first is progressive learners. So at week 0, participants expressed skepticism and caution, but in week 4, they started trusting AI. So the participants, yeah. So if you look at this example, at week 0, they are saying, oh, it did not teach me at all, and blah, blah, blah. In week 4, they are saying that, oh, yes, the AI taught me how to identify true information by cross-referencing many credible sources and so on. So there is a variation in week 0 versus week 4. Now, looking at another theme, which was consistently collaborative learner, and that was around 12 of them. So these participants began with openness to AI assistance, but with time they became more critical and explicitly asserted their dependence from AI guidance. So what we observed was at week 0, they said, yes, I think it taught me how to identify. But at week 4, in week 4, they were also saying that, oh, okay, it kind of taught me how to confirm. So they were consistently collaborative with the AI system. There was another group of people called growing skeptics, sorry. So there, what we observed was participants began with openness to AI system, but they were critical throughout. They were open, but they were also critical, which means that they were using their own brains and having conversations with AI and so on. So they were using AI as secondary tool, not as somebody they would just rely on. To sum up this entire work, what we found was dialogues with AI reduce beliefs and misinformation, but build no lasting discernment skills. So AI assistance does improve our immediate performance on discerning whether what's right or wrong, but we develop a reliance on it, and that lead to a decrease over a month when tested on items that people did not see before, and that decrease was 15%, which is substantial. So yeah, this sums up my presentation. And if you want to read more about this work, you can scan the QR code, and I'm happy to take more questions.
Just one general question. How long did this take you to do?
The study went for 1 month, 3 sessions, and each session was around 45 minutes.
And what about the general technology to interface with the LLM and your search tools?
Oh, so as I talked about in my system design, I can go back to the system design slide. Yeah. So the system design is inspired by a recent work on conspiracies, which said that dialogues with AI reduces humans' belief in conspiracy by 22%, and they used GPT-4o. When we started running the system, that was the state of the art for dialogue generation back then and persuasive dialogue generation. So we just tested it on GPT-4o, and a Google custom search was happening in the backend.
No, but how long did it take you to build the system design?
Oh, so how long it took for us to build the system design? Well, that's a so I mean, it was running a lot of React code and JavaScript code and so on, and we did a pilot study before this. It took around, I don't know, I would say probably a month or so to make sure everything is getting data, I mean, logged. We are combining it with Qualtrics. Qualtrics is another platform wherein we are logging all the data. So a lot of times there were challenges. For example, we were reporting data on Google Sheets first, and we felt that when a lot of people, let's say 100 of them, are interacting with our system, we were losing some data. So it went through a bunch of iterations, and I would say probably 1 month or so. I don't know. Yeah.
But within a year, you did all this in a year?
Sorry.
Within a year? Within a calendar
Oh.
year?
Yeah. Pretty much a month. Yeah.
Excellent.
I have a question. Can you hear me?
Yes, I can hear you.
Just
Thank you.
okay. So if the human discernment went down 15% in a month after after essentially being trained by the chatbot on discernment, do you have the control of the humans who never saw the chatbot? How did they do?
Oh, so that's a great question. We this work is under review at Kai, and we got the same question that did you had a control group on people who actually never interacted with the system. So we did not had a control group, and that's a that's a limitation of this work. What we wanted to do was a longitudinal study, but ideally it's good in Kai studies to actually have a control group. Unfortunately, we didn't. Yeah. Does that answer your question?
Yes, it does. I guess I am a little curious as to why
Yeah.
not. right?
Yeah.
Because you'd want to know what
Right.
the placebo effect essentially, right?
Yeah, it makes sense. We were actually trying to compare two systems, persuasiveness versus critical thinking, like probing humans with Socratic questioning methods to make sure AI is asking enough questions and then analyze. So that's the next study that's the next work that we are gonna release, and that would have the control group and so on. So it was not no AI versus persuasion, but it was persuasion versus critical thinking.
I see.
Yeah.
Thank you.
Yeah. Are there more questions?